Guys, in the last video, we talked about the pump, and we said the purpose of the pump is to pump your eluent through. And if you have this pump, and if it's running every single day for hours on end, you know as good as well as I do that pump is going to have some maintenance. So the last video, we kind of walked you through a video that showed you how to take the front pump off, just really holding on there with 4 screws, and then taking the pistons off of the back that just get screwed off, and then replacing some of those pump seals on the inside that prevent some of that leakage. This is kind of a cross section of the pump once it gets installed. So basically what you're seeing here in this picture is this piece of tubing up here at the top. Think of maybe like this eluent coming in on the inside of your mobile phase and kind of going through and out the other end. So I think I've drawn actually that a little backwards. So this top one is going to be the eluent coming out, and this bottom one is going to be your eluent coming in. So this is going to have some sucking action, right? So your liquid's going to come through. It's going to go through that tubing that they disconnected in that video in the last one. That was the bottom screw that they took off and they capped. And then it's going to go through the pump, up through the center, and then it's going to come out the other end, and it will go on to maybe your guard column or your column in the next step. Well, in order for that sucking action and that flow to happen, this pump has to have a piston, and this thing will go back and forth. So this is the metal bar that you saw them unscrew to get to the pump seals, and this thing basically goes back and forth, back and forth, back and forth, and it sounds like a squeaky little rocking chair, or it sounds like a porch swing that's kind of rusted, but that's kind of the noise that you're going to get from it, and that rocking motion is going to help you basically push the mobile phase through the system. So it's very important that these things stay clean. That way nothing's going to gunk up around the outsides of them and prevent that motion or that flow from happening. Okay, so this gives you an idea of how that pump is basically working from a side view, showing you the back end that gets to my instrument, and this is the front end on this side that you're not seeing, but this is the side that you would see if you open up the cover and look at it front face like we did in that video. All right, so this kind of gives you maybe a better idea of what's happening and the structure of the inside of that pump and what's going on as far as the way that it works and how it takes care of the mobile phase from that point. So let's go back and take a look at some of those other videos. You know, there were a couple of others that focused on the pump. So let's see what else we can do that concerns the pump that's part of the preventative maintenance and making sure that it's going to work the right way for us. So in the previous video, we've already talked about dismantling the pump head. So we saw how to take that piece off. And then we saw about replacing the seals. So we saw that the pistons were unscrewed. We used that specialized tool to pop it down in there and screw and pop out that seal. And then we took a new seal that was clean, used a guide tool to basically put it where it needed to go. And then we just kind of pushed and popped it into place. Now what we're going to do is we're going to click on this inlet valve and the outlet valve. Notice how they spelled valvet. Okay, I guess they left the T off in inlet, and that T went on to the word valve. So we have a inlay valvet. So let's take a look at the inlay valvet and the outlet valve for the IC instrument. So I'm going to blow this up a little bit for you a little bit again, and we're going to take a look at how to kind of do maintenance on these pieces too. So this piece is going to get screwed off. And the inlet and outlet valve is this big piece here, this kind of big nut looking thing that you're seeing right there. This thing just gets tightened up with a wrench. You just unscrew it out of there. And there's going to be an interior, what I would call an interior filter in a way. So this piece is going to be popped off, and that little piece there on the center is going to slide out. There's going to be an area here that needs to be cleaned. If you've got some gunk buildup, either in your sample or your mobile phase, what you're going to see happen is that this piece can get gunked up. And if it does get gunked up too much, you might as well just go ahead and replace them because it's going to be very hard to clean these out. It's almost going to be impossible. You can put them down into some methanol. You can put them down into a ultrasonicating bath if you want to. But quite honestly, once these get just to the point of no return, they really are no return. It's going to be easier just to trash them and to replace them with a new one. So what you're going to see them do is that they're going to take this piece that has a small little membrane filter on the inside of it, and they're just kind of squirting water in one direction. This will only flow in one direction, and that's what you're seeing with the arrow here. So if you look, if they flip this thing back around, one way will not allow flow of liquid, and you're going to see them kind of back end and back flush on you. As they squirted it through the front end, though, the liquid went through without a problem, and that's a very good sign that it's staying clean. There's also a bottom one here as well, so they're going to take the bottom one off, and they're going to do the same process there. That just gets unscrewed, and then you're going to take that inner filter, again, is really how I view it, and that slides out just like the top one did. It's basically the same size and the same part, really. There's no differences in them at all. And then they're going to do the same thing there. They squirt water through one direction. You see it came out of one end. They flip it around. And when they flip it around, because it's only supposed to go one direction, it should not flow out of the other end. And you're going to see the water drops are going to come out of the front where the nozzle's at and not on the back side. So again, that's a very good sign that these things are clean. They're not broken, they're not damaged, and they're doing what they're supposed to be doing. So that's another piece of the pump that needs to be taken care of over a course of a regular time interval. You want to make sure that those always stay clean. You want to make sure that those always have new pieces on them. And if not, order them and put them on there. They're not that expensive, and it's always like changing the oil in your car. You want to kind of do that to prevent problems from happening, not to wait until the last minute when your car is getting ready to break down. Okay, it's not going to help you. The next one's de-aerating the pump. So now that I've taken all of this off and I've replaced the seals on the inside where the pistons are, and I've cleaned everything with methanol and isopropyl alcohol, and then I took the inlet and the outlet valves and I took those off and kind of cleaned those to make sure that those were working the proper way. I'm going to have to put everything back together, right? And I've just incorporated air into the system by doing that. I've unscrewed this piece. If I go back to the high pressure pump, I've unscrewed this piece. I've now unscrewed that piece. I've unscrewed this piece. And now what we're seeing is that air it's going to get trapped in the line. There's no way around it. So when I put all of this back together and I screw this back on and I screw those valves back on, and then I go back and I put in my pump to the holder and I screw those back in, I have introduced a huge air bubble on the inside. And we do not like air bubbles. We do not want our air bubbles to go to the column. So that is the purpose of de-aerating the pump. We call this purge. We are purging the pump. So what's going to happen in the purge is that you're going to go to the purge pump or the purge accessibility pump, and that's going to be here. And there's a knob here in front, and you're going to see them turn it. Turning that open will allow the mobile phase to get bypassed, not reach the column, but there's going to be an exit, and that exit is right here to the left. And that's what you're seeing this tubing connected to with the syringe. So what's going to happen is that I've got my syringe here at the end of this piece of tubing. I have opened up the purge valve, and I'm going to turn the pump on. I know that there's an air bubble present. The purpose of that purge is to get it out of there so it doesn't cause problems later on down the road. And then I'm going to turn the pump on, and that air bubble is basically going to pump itself out of the system and into the syringe, and then I'm going to see a flow of mobile phase. When I see a flow of mobile phase that happens in that syringe, then this gives me a very good idea that things are happening the right way and that I'm getting mobile phase now if I close that purge outlet closed off. All right. Here is the screen that you're going to see for the purging. This is typically found in the manual button over on the bottom left-hand side of the screen of the software. When you click manual, this screen will pop up. You can kind of see up here it says manual control. This screen will pop up. And what you can do is that you can click on the pump icon that's right here up front and center. Okay? When I click on the pump icon, all of these kind of options down here are going to activate, and it shows me the flow, which is right now set at 0.7 mils a minute. It shows me the P min and the P max. So this is minimum pressure and maximum pressure before the system cuts itself off. What I would want to do with the purge is that I'm going to go to the pressure minimum, and I'm going to change that to 0. The reason I'm changing that to 0 is because I'm opening up the purge valve and I'm trying to get rid of an air bubble. And I know that this system is not going to hold any type of pressure at all because I've opened it up. If this had a number there, let's say a 1, when the machine falls below a 1, it stops. It doesn't pump anymore. So if I turn the pump on and I have the purge valve open, then whatever number is there is going to plummet and it's going to go way below 0 for me. And when that does go below a 1 and goes closer to 0, then that machine is going to turn itself off. And I will not be able to purge my pump because of it. So always remember, change that number to 0 when you go into purge. That is not a default setting. I wish it was, but it's not. The P max, that is the maximum pressure before the machine cuts itself off. This helps prevent some damage to the machine. If there's a clog or something that's going on in your column or in a tubing line, and this thing begins to build up pressure and it goes higher and higher and higher and higher and higher, it can blow, right? And when I say blow, well, I don't really mean exploding machine on the countertop. What I do mean, though, is the peak tubing will begin to explode. Maybe it will begin to leak. Your column can get damaged, and the conductivity can also get damaged because of it. So this pressure max, I never really change. That's a default setting from the instrument company, and I really just kind of leave that as it is. The flow rate, though, I don't want to wait forever for the flow to come through. I normally crank this up to about 2 mils a minute. I let the pump work a little bit harder. It's not going to go through my column, so I'm not going to build up tons of pressure. I've got this purge valve that's opened, and I don't really want to wait and wait and wait and wait and wait for 0.7 mils a minute. So I normally change this to a 2, and then after I do that, I change that to a 2, this to a 0. Don't touch that one. And then I hit the start. And that allows your purge flow to begin. That's what you're going to see them do here. And this pump turns on. The purge valve opens up, and I'm seeing liquid mobile phase that gets captured into that syringe. And that lets me know that that air bubble now is pretty much gone. Finally, this opening the purge valve, I don't really think that I have to play. It's a very short video, but this just kind of tells you what you probably need to do when you open it up. Just keep an eye on the software. What you're going to see is that they're going to stop everything from running, and they're going to open the purge valve up, and notice how this pressure plummets. It gets lower and lower and lower and lower. That's a sign that there is a open thing in your system. This pressure is decreasing, and that's a very good sign that you can go on to the next stage and kind of do what you need to do from that point on. All right, so that's a little bit about the pump area of the instrument, and I think that that gives you kind of a better idea of the maintenance and the care that needs to come along with having an operational pump on an IC system. So liquid chromatography is not something that is going to be very easy to manage and take care of. It really is somewhat of a high maintenance system, and that goes for ion chromatography and high performance liquid chromatography. You know, there's things that are going to get messed up, and you just got to be ready for those, and you got to have a basic understanding of maybe where you could start to fix those problems if something goes on. All right. How do I know if my pump is actually dirty? Is there a sign? Is there something that I can maybe take away as far as what's going on? Well, number one is I'm not getting any kind of sample. All right. Let's say that on my chromatogram, I've injected a sample and I see just kind of blobs that are coming through. And those blobs aren't really kind of peaks that I would associate with as a chromatogram. That's a very good sign the pump is damaged or the pump is not working, because the pump relies on the mobile phase, or the mobile phase relies on the pump. And if the mobile phase is not pushing through, it's not pushing your sample through the proper way either. So you're not going to see chromatograms. You're not going to see peaks. There's an issue with the pump somewhere, and maybe it needs to be cleaned, and maybe it needs to be taken apart, and you need to get all that gunk out of there and then put it back on, and maybe, cross your fingers, you'll get a chromatogram after that. All right. The next thing that you might see with a dirty pump is something that we would call a noisy baseline. You know, that stuff can kind of build up gunk on the inside of it. And if you take a look at the baseline, if you zoom out long enough or far enough, everything looks like a flat line, right? But on a normal kind of working day, if you see the baseline kind of do this jiggity jaggedy stuff on the screen, then that is a very good indication that there's gunk in the pump. And that gunk could be in the pump, it could be in the tubing, it could be anywhere. And that noisy baseline is basically all of this dirtiness that's getting carried through the instrument, and it's reaching the detector. So again, a very good sign that you just need to stop everything that you're doing, take off the pump. I know that you might dread it. I know I do, because getting it back on without any leaks, well, to do it the first time all the way through without any leaks, I've got to give it to you. I'll take you out to dinner if you can do it. But that noisy baseline is a problem, and maybe an unequal or nasty looking chromatogram is also going to be a problem. Notice that they kept rinsing things out. The normal kind of run-of-the-mill wash here for all of the pump seals, the valves, the pistons, and all of the other things. Number one is that you want to kind of rinse it with DI water first, just to make sure that the gunky kind of nasty stuff is off. The cleaning agent normally is going to be isopropyl alcohol. I abbreviate that as IPA. Isopropyl alcohol, or rubbing alcohol, basically, is what needs to go there. Some people do use methanol. That's typically okay. I've used methanol before in the past. No big issues with the methanol that I've seen, but IPA is probably a little bit easier, a little bit cheaper. Methanol, though, does as good of a job, and we have it all the time, it seems like, in our instrumentation room, because we use it to clean other stuff with, too, at the same time. And finally, number three, we're going to rinse one more time with DI water, just to kind of rinse off any kind of extra stuff that might be present. And finally, number four, what they would really like for you to do, if you can remember it, is that you are then going to rinse all of the pieces with the eluent that you are using on the machine. So if this is an anion setup that has a bicarbonate-carbonate mobile phase, what they would like for you to do is to take some of that mobile phase and just rinse off all of these pieces with it, so that way it can be primed and prepped for the mobile phase that will begin to come through. You're not contaminating the mobile phase that's currently in your lines with DI water or isopropyl alcohol or methanol as it makes its way through the system. So those are kind of the general guidelines about washing and rinsing when you can do that. And you need to do that with the pump. You need to do that with the pistons. You need to do that with the valves. And you also need to do that with the seals. All of those are very, very important when it concerns the pump maintenance.